So our next chapter is polynomials, and this is the first lesson, that is 2.1a, multiplying binomials. So let's see, what is a polynomial? You must have done this in grade 9, so it's just a review of that. A polynomial is an expression of one or more terms combined. Combined means they can be added or subtracted together. Examples are, if I say x plus 5. Now there are two terms, x and 5, and they're separated by a addition. They are being added together. 2a squared minus 6ab plus 18b squared. Again, I have three terms, and they are separated by addition or subtraction sign. Or simply 4a squared b. It's just one term, right? Now let's complete this table and see which ones are binomials and what are binomials. Now the first one, we have only one term here, right? There's no other term, there's no positive plus sign or minus sign, so it's just one term. When we have one term, that type of polynomial is known as monomial. Now in the second one, there are two terms. One is 4x and one is 3w squared. How do you find out that there are two terms? They both are separated by this addition sign. So there are two terms. When we have two terms, it's a binomial. Now in the next one, we have only one term. There is no plus or minus signs. It's just one term. Again, one term means monomial. The next one, see how many terms are there which are separated by a plus sign and a negative sign. So we have 1, 2, and 3. So there are basically three terms, and when we have a polynomial with three terms, we call it a trinomial. Similarly, next one, 1, 2. So two terms, which gives this is a binomial. And the last one, let's see how many terms are there. 1, 2, 3, and 4. So four terms. So when you have four terms, it means this, we call that as a polynomial. Now which ones are the binomials here? I had 2, 1, and this one. These are the binomials. Let's find out how many different ways we can calculate the area of this triangle. This will help us to find out the way to multiply the binomials. This is the area model which we'll work on. So this side is 10, this is 3, 4, and 2. If we have to find the area of this rectangle below, we can do it two ways. Either we can find out the area of these four separate triangles. This is 1, this is 2, this is 3, this is 4, and then find out the total area. So area of a rectangle, the formula for that is length times width. So for this one, the length is 10 and the width is 4. So area will be 10 times 4, 40. In this triangle, length is 3, width is 4, so area is 12. This one, it's 10 times 2, so area is 20. The last one, it's 3 times 2, area is 6. So it means the total area of this rectangle can be, we find to add the area of all the small four rectangles, 40 plus 20 plus 12 plus 6, which gives us 78 units square. Unit square, since I don't know the units, meter, centimeter, millimeter, so we do unit square, and area is always measured in square units. Another way of finding out the area of this rectangle is just to multiply the length and the width. If I look here, this length, 4 plus 2, so the total length is 6, and this one, 10 plus 3, so total length is 13, right? So it's 4 plus 2 and 10 plus 3, which is 13 times 6, which is also 78 units square. And in both the cases, the area is same of this a rectangle. Now let's use this strategy of area model and find out the dimensions of some other rectangles where we have the algebra tiles. Now this area is represented by the dimension x plus 3 and x plus 1 where the algebra tiles are there, and we have to do this by area model. You must have done algebra tiles in grade 9. If not, so this rectangle tile, I'll just quickly go over that before we move on to that. So a square, all the sides of the square are same. X, let it be x. So area of this will be x squared. So a square tile is x square. A rectangle tile like this where the length is x and the width is 1, x times 1, the area of this tile will be x, and the small square with the side is 1 unit length, area of this small tile is 1. So similarly in here, this is x, this tile is 1, 1, 1, 1 and 1. So this represents x plus 1, 2, 3, and this represents x plus 1. Now if we multiply these two tiles, x times x gives us x squared, which is a square tile. Then x times 1 is x, which is a rectangle tile. X times 1 is x again, a rectangle tile, and then again a rectangle tile. Now 1 times x is also x, so there's again a rectangle tile. 1 times 1 is 1, so small squares here. I'm going to shade these tiles because the shaded tiles means they're positive. Right? So let's see. I have x squared. How many rectangles are there? 1, 2, 3, 4. So plus 4x. And how many small tiles are there? 1, 2, 3. So plus 3. The shaded ones means they are positive tiles. Now let's do it with the area model. So for the area model, how do you think you will be able to do it? Again, I'm going to divide my rectangle in 4 parts. One side represents x plus 3 and other side represents x plus 1, which is given to me. So x times x is x squared, x times 3 is 3x, 3 times 1 is 3, and 1 times x is 1x, this 1 and this x is 1x, and 1 times 3 is 3. Now here we combine the like terms. These are like terms. So when we combine the like terms, what is the resulting polynomial? X squared, 3x plus 1x, 4x plus 3. So again, I have the same answer in both the cases. Let's do one more of this type. How do we represent x plus 5 times x plus 2? X plus 5 times x minus 2. I have a minus. So what is the product? And let's do it with both the ways, area model and with algebra tiles. So with algebra tiles, the way I'm going to start is, so x plus 5. So x means one rectangle and it's shaded because it's positive. Then 5 of these small tiles. 1, 2, 3, 4, 5. All these tiles are shaded because 5 is positive. Now x minus 2. Again x, which is positive, and minus 2. So I'm going to keep these tiles unshaded. Now let's start multiplication. X times x is x squared, shaded because it's positive. X times 1 is x. Again, x times 1 is x. I'm going to repeat it for 5 times. Now look here, a negative 1 times x. A negative 1 times x gives us a negative x. So this is the x tile. I'm not going to shade it because it's negative now. Again, a negative x. A negative 1 times a positive 1. All the negative ones. Now let's see. This negative tile and this positive, they are cancel out because plus 1 minus 1 they cancel out. Similarly here, plus x minus x they cancel out. And what are we left with? 1x square. How many x there? 1, 2, 3. 3x. And how many negative ones are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So minus 10. So that is my solution if I use algebra tiles. Let's do the area model. The same thing, I'm going to make a square or a rectangle. X plus 5, x minus 2. So x times x is x squared, 5 times x, 5x, minus 2 times x, minus 2x, and minus 2 times 5 is minus 10. Again, combining the like terms. So 5x minus 2x. So I have x squared, 5x minus 2x gives me 3x, and minus 10. And that's my solution. And in both the cases, my answer is same. So that's another way of doing it. Let's do the next one. In this one, we're only going to do the area model. I'm not going to show the algebra tiles. Let's do the area model. Again, a rectangle. I have 2x plus 4, 2x plus 4, and 3x minus 1. Now 3x times 2x, use the laws of exponents. 3 times 2 is 6, x times x is x squared. 3x times 4, 12x. Minus 1 times 2x, minus 2x. Minus 1 times 4, minus 4. Again, we're going to combine these like terms. So what I'm left with, 6x squared. 12x minus 2x, 10x minus 4. And that's the solution. Since we are doing remote learning, I'll not be able to give you algebra tiles to play with. So let's just do with the area model. Next one, how do we show the dimensions for x plus 3 whole square? And what is, x plus 3 whole square, and what is the product? So before I go further, I'm going to want to show you that x plus 3 whole square is never equal to x square plus 3 square. They are never equal. Okay, and why we'll be learning in this chapter later on. So using area model, let's just find what x plus 3 square. You know, I can write 4 square as 4 multiplied by 4. Similarly, x plus 3 square can be written as x plus 3 times x plus 3. Right? So again, my rectangle, x plus 3, x plus 3, x times x is x squared. 3 times x is 3x, 3 times x is 3x, 3 times 3 is 9. Combining the like terms, I get x squared plus 6x plus 9. Therefore, x plus 3 whole square is equal to x squared plus 6x plus 9 and not this one. Okay? So that's one important thing. What are the dimensions which are represented by the following, and what is the product? Okay, in this one we have this y tile. So x times y is represented by, which is a x, and this side is y. So it's represented by a rectangle tile here. Y times 1 is again 1. 1. These are y tiles. So this is x, y, y, y. And 1 times x is x. 1 times 1 is 1, 1, 1, and 1. So the resulting product is xy plus 1, 2, 3, 4, 4y plus x plus 4. All these tiles are shaded because they are positive. You have to evaluate the product when x is 3 and y is 2. So you have to plug the value in here. X is 3 and y is 2. So x times 3 times 2 plus 4 times 2 plus 3 plus 2. So that's 4. So it will be 4 in here. 3 times 2 is 6 plus 8 plus 3 plus 4. Now if we add that, what do you get? 21. So that's the product. Just so you know, this last one where we're using this Y tile, it's not there in our curriculum, so you don't have to worry about this one. So that was 5.1a, and tomorrow we'll work on 5.1b.